In this video, I'm going to talk through the worked out solutions to the semester 1 final exam review number 1. So number 1, the directions say solve the equation. I know in my head when the directions say solve an equation, my answer is going to look like x equals, meaning I got to get that x all by itself. So in this case, I'm going to draw a bar down here. I have two variables, two x terms that are on the same side of the equation, so I know I can combine like terms, so that becomes 14x minus 7 equals 28. Now that I have all the x's in the same place on the same side of the equal sign, I'm going to start doing inverse operations. So because it's a minus 7, I'm going to add 7 to both sides. That adds to be 0. I'm left with 14x is equal to 35. Then I can divide by 14 because division is the inverse of multiplication. 14 divided by 14 is 1, but 1x is just x. So I'm left with 35 over 14. I see if I can simplify this at all, meaning is there any number that both 35 and 14 are divisible by? Looks like 35 and 14 are both divisible by 7, so if I divide both by 7, I can simplify this to, would be 5 halves, which as a decimal would be 2.5. Both of those are exactly the same. You could write it as 2 1/2 as well if you wanted to write it as a mixed number. So then if I want to make sure I can check my answer, I can substitute it back in. So 5 times 5 halves plus 9 times 5 halves minus 7. If that equals 28, I'm good to go. And it does, so we're all set. Another way I could have done this is 35 divided by 14. If I wanted to simplify that, press enter. I see it's a decimal. If I want a simplified fraction, I can go to math, enter, enter on my graphing calculator, and I get 5 halves as well. All right, looking at this next one, I see a ratio equal to a ratio, or fraction equal to a fraction. There's multiple ways we talked about doing this, but the way that most students like to do this was by cross multiplication, meaning we multiply the numerator and denominator of one and set equal to the numerator and denominator multiplied together for the other. So 5 times 6 is 30, equal to 4 times 2 would be 8x. And now I need to solve for x. I can divide both sides by 8 because I'm doing the inverse. So I have 30 over 8 is equal to x. If I simplify that, because they're both divisible by 2, I could get 15 fourths is equal to x. Now I could write that as a mixed number, which would be 3 and, 3 fourths? Or as a decimal, 3.75. Either way, they're all equivalent. And again, if you had your graphing calculator, we could say we'll do 30 divided by 8. That gives you the decimal. Math, enter, enter, gives you the fraction, simplified fraction. Sorry, you can see that better here. And we can test our answer as well. So if we substitute this back in, if I do 6 divided by 2 times 3.75, and I press enter, I see that that's equal to 0.8. And 4 divided by 5 is also 0.8, so these would be equal. So I know for sure that that would be the correct answer. So all 3 of these would be correct solutions. Looking here, let f of x equals 2 over 7x minus 9. So if I want to find x, that means we don't know what x equals. I want to find it. When f of x equals negative 13, which means my output is negative 13 or the y is negative 13. So if I take this equation, I have negative 13 in place of f of x, or in place of the output, and now I need to solve. So by doing inverse operations, I can solve for x. So I add 9 to both sides. On the right-hand side, I'd be left with 2/7 x. On the left-hand side, I'd be left with negative 4. There's multiple ways we talked about solving for x in this point. So one is to multiply by the reciprocal. So one option, I could multiply by 7 halves. I can put that over 1. That would be negative 28 halves, which is negative 14. So that's one way to solve it. I could have taken this over here, negative 4 equals 2/7 x. We talked about that fraction bar represents division, so I could do the inverse of division. I could multiply by 7, and I'd be left with negative 28 is equal to 2x. And now divide by 2 to solve, and I still get negative 14 is equal to x. So that is another way to do it. We also talked about converting this to a decimal. So if I did 2 divided by 7, that would be this guy right here. And if I divide by that, because I have x times this, the inverse would be dividing. I could do negative 4 divided by that previous answer. and I still get negative 14. So multiple ways to do this problem as well. To find f of negative 49 means that the input is negative 49, or x is negative 49, and I want to find the output, or what y is. So if I take this, f of negative 49, I replace x with negative 49. I always like parentheses when I substitute just to make sure that we have the order of operations correct. So now I simplify this right-hand side. I can put that over 1. Now before, when we were multiplying these fractions, we multiplied the numerators and the denominators and then simplified. Well, I'm going to talk through how to simplify first. So I see that 7 is on the denominator, 49 is in the numerator, which tells me that I can simplify both by dividing by 7. So 7 divided by 7 is 1, 49 divided by 7 is 7. So now I can simplify first and then multiply. I get a negative 14 over 1, or just a negative 14. Minus 9, I get negative 23. So f of negative 49 equals negative 23, or the function whose input is negative 49 will have an output of negative 23. Excuse me, scooching down further. For number 3, it says find the slope of the function. So when I think of slope, I think of a lot of different things. I'm thinking rise over run. I'm thinking of rate of change. I know we had a slope formula. And in this case, when I'm looking at the table, what comes to mind is that the slope, we'll use a lowercase m, is equal to the change in y over the change in x. So I have to see how is y changing and how is x changing. So as I look at this, I see that we are decreasing by 6 here. We're decreasing by 6 again, again, and again. Here we are increasing by 2 each time. So we see that it's a constant rate of change, which means it's linear. And then the slope would be the change in y, so the negative 6 over 2, which simplifies to negative 3 over 1, or just negative 3. So there's my slope. Here to write the equation of a line, well, I'm thinking, okay, lines, we have multiple ways to write the equation. We have slope-intercept form, we have point-slope form, we have standard form. But if I'm given a graph where I can see the slope and the y-intercept, I'm thinking the easiest way to do this will be using slope-intercept form. So that was y equals mx plus b. That's our slope-intercept form, where m represents the slope, b represents the y-coordinate of the y-intercept. So when I look at that, the y-intercept I see on the graph is right here. That's the point 0, 1, which means b would be 1. And then the slope, when I look at a graph, I think of slope as rise over run. So I'm trying to find points where I can easily see the intersection with the grid. In other words, I can easily identify the coordinates of the point. So I have those 4 there. And I'm thinking I do rise over run, rise over run. So my rise, I go up 3, which is a positive 3. I go right 2, which is a positive 2. So my slope would be a rise 3 and a run 2. It should be positive because I have an increasing function. And my b, because the y-intercept was 0, 1, will be 1. So here's my equation. Excuse me. Now the nice thing is if you have a graphing calculator, I'm going to go to y equal, turn that guy on first. Go to y equals, let's clear this out. I type in 3/2 x plus 1, and if I go to the graph isn't going to look exactly the same because the scale might not be the same, but we can see that it is increasing. If we look at the table, we can see that the y-intercept is 1, and let's go to the next point. When we had 2, this would be the point 2, 4. So let's make sure 2, 4 is there, and indeed it is. And you could do that with other points as well. So graphing calculator makes it so we can check our answers, which is nice. Looking down here, it says, what is the y-coordinate of the solution of the system? Well, first of all, when I think solution of a system, remember that the solution of a system is the point where the 2 lines intersect. That is an x, y. The y-coordinate is all they're asking for. So that's going to be that guy right there. So when we were solving systems, we had 3 different ways that we solved systems. We solved it by graphing, we solved it by substitution, we solved it by elimination. Now we can choose any of those ways because it doesn't specify how to solve the system. Well, when I look at this, solving by graphing would not necessarily be the easiest way because we don't have both of these in slope-intercept form, so it's going to be a little difficult to graph. But when I look and I see y equals, I see that we have one variable already solved for. So solving by substitution might be my easiest bet here. So I have y equals here. I'm going to replace that y with 8x plus 7 and then solve. So we have 5x minus 7. I substitute in 8x plus 7 equals negative 49. And now I start solving. First I distribute. So I have 5x minus 56x minus 49 equals a negative 49. I see that I have variables on the same side of the equal sign, so I'm going to combine like terms. That would be negative 51x minus 49 equals negative 49. I add 49 to both sides. These add to be 0, so I'm left with negative 51x equals 0, but I can still divide by negative 51. And when I do that, I get that x is equal to 0. So I found what x is. Now remember, the solution to a system is your unordered pair, an x comma y, but it's just looking for the y coordinate. So I found x, but I need to find y. I can substitute that x equals 0 into either one of these equations, but I'm going to choose the bottom one because it already has y solved for. So I believe that's easier to solve for what that y coordinate would be. I substitute in x equals 0. I get 0 plus 7, which is just 7. So the solution to the system would be 0, 7. But when it's asking for just the y coordinate, the answer to this problem is 7. That would be your y coordinate. If I flip to the back, oh, there is no back. So we are done with review number 1.